Hi, I'd like to take a few minutes to talk to you about quadratic inequalities and why they can't be solved in the same way that we solve quadratic equations. Let me give you an example of what I'm talking about. Suppose we have x squared minus x minus 12 is equal to 0. This is actually a quadratic equation, and I can tell that it's an equation as opposed to an inequality because of the presence of equal sign. We've learned that one of the ways for us to solve a quadratic equation is to factor and then use something called the zero factor property to find the values of x that make the equation true. In this case, I would be looking for two things that multiply together to give negative 12 up to negative 1. The two numbers would be negative 4 and positive, so this quadratic factors into x minus 4 times x plus 3. And so using this to replace the original quadratic means that x minus 4 times x3 is to 0. Now's when we'll use the zero factor property. The zero factor property says that whenever we multiply two terms together and get a product of 0, that means that one or both of the factors must be equal to 0. In other words, the only way to multiply numbers and get 0 is if one of the numbers being multiplied is 0. So that's why we're allowed to set up x minus 4 equals 0 and x plus 3 equals 0 as our next step, and then solve each of those for x. In this case, give us an x value of 4 and a value of negative 3. So that means in this equation, x could be either or negative 3. Now the problem with that process, which is a great process, is when students encounter quadratic inequalities. A quadratic inequality is something that looks perhaps like this. X squared minus x minus 12 is greater than 0. Or maybe like this. X squared minus x minus 12 is less than 0. A lot of times students have an instinct to just say, okay, I can still factor, which is actually, we can still factor into x minus 4 times x plus 3, and then I'm just going to set each factor greater than 0 or less than 0 as opposed to equal to 0, and that's where they fall apart. In order to figure out what we're actually supposed to do, you have to think about what the meaning of this part of the expression is. Greater than 0. When we talk about numbers that are greater than 0, we're talking about things that are positive. And so really we're trying to find two things that are going to multiply together to give us a positive number. There are two ways that that can happen. We can have either a positive and a positive, or we can have a negative and a negative. If we're looking at a situation where we have the quadratic less than 0, then again we can use the factored form. But we can't just say the factored form itself has to be less than 0. Because in order to find things that are less than 0, we're trying to find ways to create a negative answer. And so if you think about that, in order to create a negative number, I either have to have a positive with a negative or a negative with a positive. So you can see that if I were to just take this problem and say, okay, x minus 4 has to be greater than 0, and x plus 3 has to be greater than 0, well, that would capture this option, but it would miss this option. And if I were to have this problem and I said, okay, x minus 4 has to be less than 0, and x minus 3, sorry, that should be an x plus 3, and x plus 3 has to be less than 0, then I would actually be telling myself that I needed two negatives, which doesn't match this at all. It actually matches this option. So in that case, I'd get the problem completely wrong. There are a few different ways to tackle quadratic inequalities correctly. Let me show you my favorite of those. So I'm going to choose just one of these problems. Let's do the one where we have greater than 0. Although you'll see that the process is actually the same regardless of which problem you're doing. So we'll start with the factored form. And then a reminder that we're looking for positive values. And the next thing I'm going to do is to create a sign graph. A sign graph is just basically a number line. And around the number line I'll be putting locations for where the values are going to end up being positive or negative, and where they're equal to 0. And so I know from our previous problem, and I know from the zero factor property, that if x is negative 3 or 4, then that's going to make this quadratic equal to 0. And so I actually want to put those on my number line. From there, I'm going to determine what each area of this graph does. There's a really great property. It has to do with the nature of continuous functions, which a quadratic is. That tells us that anything that I pick that is in the same location to the left or right of this 0 is going to have the same behavior. So if I pick any number to the left of negative 3 and plug it back in, if it's positive, then that's going to be the same behavior as every number in that location. Same thing if it's negative. So I'm going to pick a number that is smaller than negative 3. So let's say negative 4. And so what I want to do is look at and see what happens if I put negative 4 in for both of these x's. And I'm not really concerned with the value of the number. I'm just concerned with, is it going to be positive or is it going to be negative? And so looking at this, if I put a negative 4 into x minus 4, negative 4 minus negative 4, that is a negative number. If I put a negative 4 here, negative 4 plus 3, that's also a negative number. Now remember, I'm going to be multiplying these two things together. When we multiply two negatives together, that creates a positive. And so that tells me that everything here to the left of negative 3, any value to the left of negative 3, is going to create a positive answer. Now I'd like to do the same thing for some number between negative 3 and 4. A really good sample point would be 0. That's an easy one to plug in. 0 minus 4 is a negative number. 0 plus 3 is a positive number. When I multiply a negative times a positive together, that gives me a negative number. And then finally I want to look at the interval that contains the numbers that are greater than 4. So a number greater than 4, for example, is 5. I could also choose 10, 100, a million, doesn't matter. If I do 5 minus 4, that's 1, which is a positive number. 5 plus 3 is 8, which is also a positive number. And when I multiply two positives together, that gives me a positive. So now that I have my sign graph, I can answer the question that was posed to me, which is to find the values of x for which x squared minus x minus 12 is greater than 0. In other words, positive. And so looking at my sign graph, I know that that's going to happen on this interval, which is from negative infinity to negative 3. And I'll write that in interval notation. Note that I put parentheses on the end where the negative infinity is. We always have parentheses at the infinity values. I also put parentheses where the negative 3 is, and that's because in this situation I'm not allowed to have values that equal 0. If this had a line under the inequality, then I'd have a bracket there. I also have another interval where I have positive values, and that would be from 4 to positive infinity. So I'll go ahead and put 4 to infinity, and again I'll have parentheses there. Put the union symbol between it since it is a value of x in this interval or in this interval. And that would be my solution for places, values of x where this quadratic is greater than 0. Note that if I had wanted to find the other problem that I had posed here, places where the quadratic is less than 0, then I would simply be naming the interval that corresponds to the negative part of my sign graph. So that's a little bit about quadratic inequalities. I hope that it's helped you to understand why you can't do the same process as you've learned to do with the zero factor property, but instead have to use the meanings of these inequalities and their relationship to 0 to create a sign graph and look for positive and negative values.